Okay, so in this video, I want to explain more about the chapter 26 that we might have enough time to discuss during the class time. Okay, so the carbonyl compounds, we will start with the chapter 26.3 until 26.5 because chapter 26.1 and 2, we have already talked about it. It is talking about the aldehydes and ketones and how they react. Remember, they react by the nucleophilic addition reactions. We talked about that already. So now let's move on with this 26.3, carboxylic acids and ester. Okay, so here are few examples of carboxylic acid compounds. Okay, I want you to pause the video and write the name for each of the compounds. Okay, and then after that I will click this out and the answer will come up, so you can just check it out, your answer whether it's correct or no. Okay, right, so start from the left here. We have a very simple, the simplest carboxylic acid. This carboxylic acid group, COOH, just attached with a hydrogen. So in total only have one carbon, so we will call it as a methanoic acid. Okay, the second one, ethanoic acid. The third one, we have the bromine atom attached in the carbon number 2. So the name will be 2-bromo-propanoic acid. And this one, we have methyl group attached in the carbon number 3. So 3-methyl-butanoic acid. And for this one, the carboxylic acid group attached in the benzene ring. So we can call it benzoic acid. Yeah, benzoic acid is the common name. Yeah, we can also name benzene carboxylic acid, the longer name. Okay, next with the physical properties of carboxylic acid. First, it is soluble in water, but only up to butanoic acid. So more than 4 carbon chain length, then the solubility in the water will be reduced. Why that the carboxylic acid can soluble in the water? Because there will be attraction with the water molecule, yeah, by the hydrogen bonds that is formed between the lone pair of oxygen attached in the acid with the hydrogen atom of water molecule. And it also can form a dimer molecule. So two carboxylic acid, they are bonded together by the hydrogen bond forming a dimer. And then the other physical properties of carboxylic acid, that it has higher melting points than compared with the alkenes with similar MR value. For example, ethanoic acid with the MR value 60, with butane, an alkene with the MR value almost similar, around 58. And the acid will have higher melting points compared to the alkane. Again, it is because the presence of hydrogen bonds between the molecules thus make the molecules have a stronger attraction between each other, hard to break the bonds. So we need more energy to break it. Okay, here are the tile tube. This tile tube used to measure the melting point. Okay, if you want to have more detail about tile tube, you can just find on YouTube how this tile tube work. But it is not needed for in the syllabus, so it is just for additional information. And the last one, that it has characteristic smell. Yeah, acid, like for example vinegar, right? It has a unpleasant smell. Yeah, that characteristic smell. Yeah, that produced from the acid. Okay, the next one is the reactions that form carboxylic acids. We already learned this. So when we can make carboxylic acid from the hydrolysis of nitriles. Hydrolysis means that there is a presence of water, right? So this water will react with the nitriles. So let's see. So the propane nitrile react with the water under the acidic conditions. Okay, so this N, the CN, right, let me write here. The CN, right, will become the COOH. So the group is changed. And then also produce the side product, the ammonium chloride. Okay, the reagent that is needed for this hydrolysis process is dilute HCl, because dilute means that this HCl is being dissolved in a larger amount of water, right? So dilute HCl means you have the HCl, you have the water, which is just shown here. And the condition is you need heat to proceed the reactions. Next is about the mechanism, but this mechanism again is just additional. You may want to know how the electrons moving and how the intermediate products are, but it is not necessary for these particular reactions. Okay, and then move on to the reactivity of carboxylic acid. Yeah, how it will react with another compound as an acid particularly. Okay, so this COOH group, as you can see, yeah, it is quite polarized. The oxygen, these two oxygen bear the partially negative charge. The carbon and the hydrogen bear the partially positive charge. So this partially positive carbon center is vulnerable to be attacked by the nucleophiles. And yeah, in the other side, this oxygen, which bear the partially negative charge, is able to attack, it is also prone to be attacked by the positive charge species. And the hydrogen, in this case, it is easy to be lost, released as a hydrogen ion, which means that this compound can behave as an acid because of it can produce H plus ion. Carboxylic acid behaves as an acid. So yes, it is an acid, however, it is a weak acid. It has a small acid dissociation constant value. But even though this is a weak acid, it is not as weak as alcohol. Still, carboxylic acids are stronger than alcohols. Okay, again, let us see, yeah, why this acid, how it lose the H plus ion. It is because of due to the presence of carbonyl group here. Yeah, it will withdraw the electrons. Yeah, as you can see, the arrow is going towards the carbonyl group, and thus that the OH bond here is weakened, easy to break, and thus easy to lose as the H plus ions. Yeah, forming the acid carboxylate ion here, and this carboxyl ion is stabilized due to the delocalization of the electrons around the COO minus group. Yeah, as I already explained also during the class, that it means that between these two structure, yeah, there is a resonance, that the electrons are moving, yeah, the electrons are delocalized, and thus make these ions are stable. Right. And here, yeah, whenever we have the presence of an electron withdrawing group, such as the halogen group, fluorine, chlorine, bromine, right, it will even more weakens the OH bond. And thus, yeah, this type of acid with the electron withdrawing group attached to it, it will give you a more acidic substance. As you can see, compare with the normal acetic acid, with the one having the chloro in this the same carbon like here. So the acetic acid, the pKa is 4.8 pKa, okay? pKa is 4.8, and this one, the pKa is 2.81, and as the pKa value is lower, then the stronger the acid is. Okay, move to how this carboxylic acid would react with the other compounds, such as the metal carbonates, alkalis, metal oxides, and metals. So how this our acid react with these somewhat basic substances. Okay, so we have ethanoic acid. First, it reacts with sodium hydrogen carbonate. Okay, and then the second one with the sodium hydroxide, and then sodium carbonate, and with the magnesium metal. So again, pause the video and try to do it first by yourself. What will be the product obtained when you combine these two starting material? Okay, so for the first one, ethanoic acid with the sodium hydrogen carbonate, you will get the salt. What else? You will also have the water and carbon dioxide. Okay, because of the presence of this hydrogen carbonate. And you will also expect the same thing produced when you react ethanoic acid with this carbonate compound. You will also get the water and carbon dioxide. Okay, for the second one, acid with a base, very simple. Yeah, produce salt and water. And for the last one with magnesium, yeah, remember when you have acid with a metal, then you will get the salt and hydrogen gas. Okay, knowing that carboxylic acids cannot be oxidized any further, so we talk about the reduction of the carboxylic acids. Reductions means that it is shown by reacting with the hydrogen here. If oxidized with oxygen, but if reduced, will be with hydrogen. Okay, so a carboxylic acid will be reduced to become the alcohol, yeah, with four hydrogen here. Okay, so you can also calculate that the number of hydrogen on the left and on the right should be the same as well. Okay, for the reagent needed is the lithium aluminum hydride using the dry ether, and the solvent must be dry ether because lithium aluminum hydride is very reactive. Yeah, it will give violent reaction with if there is a presence of water. And then the condition is room temperature is enough because again this is a very strong reducing agent. Okay, so this will be the what the equations looks like. Okay, you see the carboxylic acid, this carbonyl group, yeah, it will be reduced, and then it's just become the two hydrogen atom attached to it. Okay, and then it will also produce off our side products here.